Hi, physical science kids. We are in our bonding and ion notes, part 1. So we're going to start out today talking about how do we count atoms. Now, this should be pretty simple for most of you. What if I had a helium? Okay, how many would I have? I'd have one helium. Okay, but what if I have a bunch of heliums? What if I have 3 heliums? Okay, well, that's pretty easy. Okay, we can say there are 3 heliums, but how do we write that? Well, there's some multiple ways we can write it. We can say, well, there's 3 of them. Okay, could we write it like this? What about this? And then some of you might be thinking, well, mathematically, there's this thing up here called an exponent. Okay, so we've got to talk about all these things, and we got to make sure that we're on the same page with all that kind of stuff. All right, so we're going to go through a little bit here and talk about that. First thing I want you to do, though, is take a guess. Either pull out a piece of paper, or you can have this up, whatever you want to do, or if you just want to kind of guess in your head, I want you to think, how many carbons are there, hydrogens, and oxygens are there right here? So I want to know what's the number of each of those. And then down here, I want to know how many hydrogens and sulfurs are in this one and how many carbons and hydrogens are there in this one. And I want you to write your guesses down in here. So take a second or two, or pause the video and take a guess right now. Well, hopefully you've taken a guess. Okay, hopefully you've taken a guess. And we will go over this later, but we'll talk about it here in a second. But real quick, the answers were 1, 2, 1, 4, 2. Then actually the answer to the next one is actually 32. Excuse me. Yep, 32. Oh goodness, what am I doing? 32 and 4. And if you didn't get those right now, that's okay. We're going to try it again in a little bit, and you should be able to knock it out of the park. What's important to know is that we know what a subscript is. A subscript. Now, first of all, the word sub. When you think of the word sub, you probably think of a submarine, okay, or something like that. Subs go under the water. So sub, which, Latin really comes from a Latin word to mean under. So this word really means, sub means under. Okay, the under script. And script, if you've been in theater or anything like that, you know that is a writing. Okay, so really what we're trying to say is a subscript is the underwriting of something. Okay, so if you look at this guy right here, if you look at this water, okay, if you look at this water right here, you can see that there is a subscript. Okay, there is a subscript right there, the number 2. What that means is this number shows the number of atoms of a particular element that it follows. So for example, this 2 really relates to this hydrogen, which means there are 2 hydrogens. Now oxygen doesn't have a number. Okay, oxygen doesn't have a number there. But if I write X, how many X's are there? There's 1, but there's no number there. Well, because we know there's supposed to be this number out here. There's this invisible number that we don't write that says 1X. So just like that, there really is an invisible 1 here that we don't write. So there would be 1 oxygen, which makes sense. There are 2 hydrogens and 1 oxygen. Let's practice that, shall we? Let's look at this one real quick. And if you really know what you're doing, you can pause the video and try to guess what these are, and then we can go over them later. But let's look at this first one. Let's look at the subscripts, all right? There's an 8 here. There's a 12 here. And there's a 6 here. Okay? Think about that for a second. They follow or subbed under whichever element they're talking about. So, how many carbons are there? Well, there are 8 carbons. There are 12 hydrogen, and there are 6 oxygen. All right, try the next one. There are 2 hydrogens there are 1 sulfur, because remember, even though it's not written, it's like there's a little invisible number 1 there. Okay? And then there are 4 oxygens. Okay? And then finally, the last one's pretty simple. It doesn't have any hidden ones or anything. Oh, that's not a circle, but we'll go with it. That one looks like a house, but there you go. It's 8 and 18. Very simple. Literally just counting how many there are there. So let's go back to the take the guess one. Let's go back to take the guess one. Now you might be thinking, well, this is really simple. Let's look at this first one. Think about the little invisible ones. Now, you don't have to write the little invisible ones there, but if you're somebody that feels like they need to do those invisible ones, you go ahead and do that. Okay, you go ahead and do that. It's not going to hurt anything. So the answer is 1, 2, 1. Okay? All right, now, we have to remember something about parentheses, just like in math. Okay, for example, in math, if I had x and y, we'd know there was 1x and 1y. But if all of a sudden I put what's called a superscript or something out in front of it, we know that that 2 goes to both of them, and we'd say there'd be 2 x's and 2 y's. So this is the same thing. We're going to distribute, math word, the 2 to both things inside the parentheses. So remember, this little s here had that little magical invisible 1 by it. So really it's 2 H2's, or 2 times 2 is 4. 2 times s, or 2 times 1, is 2. Okay? You can also think of this, some people like to think of it this way. What this thing's really saying, just like before, okay, with the x and the y, where we literally had the 2 out here in front, really that means there is xy, xy, which means there's 2 x's and 2 y's. Well, this literally means that there's an H2s and an H2s. And there are now 4 H's and 2 S's, which is what we've written over here. Okay? This one might be the hardest one, but all this one is saying right here is that if we have a 2 or a superscript on the outside and we have a subscript down here at the bottom, what this is saying is this subscript, remember, there's a little invisible 1 here as well. This means that this 2 goes to here. Sorry about that. I don't know why this is messing up. This 2 goes here, but it also goes to here. And this 2 goes to both of these as well. So, really what this turns into is this really turns into the number 2 from here. This turns into the number 16 from here. Now it's like that's gone. And now we have to multiply it by 2 again. So now that's 2 times 16 and 2 times 2. So 2 times 16 is 32. And 2 times 2 is 4. That one's a little tough, but I hope you could follow along with that. And if you have a question, make sure you ask about that. So how does this lead to bonding? Well, what this all leads to is the idea that if I dump in an entire bucket of O and an entire bucket of hydrogen into a box, what would happen? Well, this would happen. Okay? All right? What happens is we have hydrogen with a valence electron. Remember, we're just worried about valence electrons here. Okay? And what we have here is every hydrogen has 1 valence electron, and oxygen had 6 valence electrons. And if you notice, there's 2 empty spots. Well, these hydrogen want to come and sit at the table. Why? Because hydrogen, remember, it only has one shell, wants 2 electrons to be full, and this oxygen wants 8 to be full. And now they're all happy because the table's full and no one else can sit at their table. Okay? Well, let's look at this for a second. Sodium. If you look at the periodic table for sodium, you're going to see that sodium has 1 valence electron. It has one family, or it's in family 1, and has 1 outer shell electron. I'll change my color here. Chlorine is in family 7, so it has 7 outer shell electrons. And if we do that, we have 3 paired electrons and we have 1 empty spot at the table. Well, look, this little guy, like a puzzle piece, just wants to plug in there, and our final product is going to look like this. We can draw a nice box around that so we know that that's where all the electrons are. All right, lithium. How many lithiums are there, though? There are 2 lithiums. So we need to be able to draw 2 of them. Okay, I'm just going to draw it without the little dot for the eye because sometimes that can be confusing. But we're going to draw 2 lithiums, and lithiums are in family 1, so we know it has 1 outer shell electron each. Oxygen, remember, how many are there? Well, there's 1. Okay, so we're going to draw 1 oxygen. Okay, it is in family 6, or the chalcogens. So we're going to draw 6 outer shell electrons with 2 open spots. All right, think about the puzzle piece. This guy's going to want to come down here, and this guy's going to want to go sit at that table, place at the table. So we're going to draw our final product. Okay, this lithium is going to sit here. This lithium is going to sit here. And look at this. That oxygen now has all 8 of its electrons. Okay, and these lithiums all have their electrons that they want. Okay, and we get our nice little shape there. All right, last but not least, we'll zoom in a little bit here just so we have plenty of room. Remember, this carbon has, yep, that's right, 1, and this hydrogen has 4. So literally, carbon is in family 4, so it's going to have 1, 2, 3, 4. And how many spots does it have at its table? That's right, it has 4 spots at its table. Okay, on every side of that table, if you will. How many hydrogens are we going to draw, though? We're actually going to draw 4 of them. Okay, we're going to draw 4 hydrogens. And hydrogen's in family 1, so it has 1 outer shell electron. Hydrogen's kind of like the ultimate table guest. Well, you can kind of see what's going to happen here. One of these hydrogens is going to come sit here, another one's going to sit here, another one's going to sit here, and another one's going to come sit here. Okay? And then finally, our final product, look who's in the middle. Look who's in charge of the table, if you will. Okay, who's in charge of the table? Well, that'd be carbon. Carbon's kind of in the center of the table. We have a hydrogen on every side of the table, if you will. What's nice is, like we said, hydrogen only needs 2, and every carbon, since it's out there, wants its 8 electrons, and now it gets it, okay? And it kind of makes this kind of cross shape, if you will, okay? Knew I threw a little bit at you there, but we need to be able to count, and we need to be able to do simple little things of bonding right now, kind of just plugging puzzle pieces. But what was important about counting? When you count and you know how many are there, you now know how many to draw. Okay, you now know how many to draw over here. Okay, so we're going to practice this. All right, if you notice, the next thing on here is we have some worksheets to do. All right, and some practicing. And again, if you have questions, make sure you ask. All right, have a wonderful day.